Think about every flower you've ever seen. Red roses, yellow sunflowers, purple lavender, blue hydrangeas, pink peonies, white lilies, every color of the rainbow except one. When was the last time you saw a truly black flower? Not dark purple, not deep burgundy, actually black. You haven't. Nobody has, and it's not a coincidence. At first, this seems like a simple question with a simple answer. Maybe black flowers just don't exist because nobody bred them that way. Maybe it's just random chance. But the real reason goes much deeper than that. It involves the physics of light, millions of years of evolution, and a surprisingly ruthless biological logic that flowers have been following long before humans ever existed. Black flowers aren't missing from nature by accident. They're missing by design. To understand why black flowers don't exist, you first need to understand where flower color comes from at all. Flowers get their color from pigments, chemical compounds inside the petals that absorb certain wavelengths of light and reflect others. The color you see is simply the light that bounced back. A red rose absorbs everything except red. A yellow sunflower absorbs everything except yellow. A white flower reflects almost everything. A black flower would need to absorb everything, every single wavelength of visible light, and reflect almost nothing back. That's the first clue. Black isn't just another color, it's the complete absence of reflected light. Here's where it gets fascinating. A black surface absorbs all light, which means it absorbs all the energy that comes with it. In direct sunlight, a truly black flower would heat up dramatically, far beyond what any other flower experiences. And heat is catastrophic for flowers. The delicate structures inside petals, the pigments, the cell walls, the reproductive tissues, are all extremely sensitive to temperature. Overheat them and they break down. The flower wilts, dries out, and dies before it can do the one thing it exists to do: attract pollinators, reproduce. A black flower in full sunlight would essentially be destroying itself before it ever had a chance to bloom. But there's a second reason, and this one is even more elegant. Flowers don't exist for us to look at. They exist to attract bees, butterflies, birds, and other pollinators. Every color a flower produces is essentially a signal, a billboard evolved over millions of years specifically to catch the attention of the right animal. Here's the problem with black. Bees, the most important pollinators on Earth, see the world differently than we do. They see ultraviolet light that's invisible to humans, and in the ultraviolet spectrum, a black flower would be almost completely invisible. No UV reflection, no signal, no pollinators, no reproduction. A black flower would be the biological equivalent of a billboard with the lights off. It wouldn't attract anything. It would be invisible to the very creatures it needs to survive. Evolution doesn't keep things that don't work. Over millions of years, any flower that developed true black pigmentation simply died out because it couldn't attract the pollinators it needed to reproduce. The flowers that survived were the ones that reflected light in ways that pollinators could actually see. Now here's the interesting footnote. Some flowers come very close. Black tulips, black dahlias, black pansies, these exist. But look closely, and they're always deep purple, dark maroon, or near black burgundy, never truly black. Plant breeders have spent decades trying to create a genuinely black flower. So far, nobody has succeeded. Because the moment you push the pigmentation dark enough to appear truly black, the flower stops working. It overheats. Pollinators ignore it. It dies. Nature keeps drawing the same line, and no amount of human breeding has crossed it yet. So the next time you see a flower, any flower, remember that its color isn't decoration, it's a solution. A millions of years old answer to the question of how to survive, attract the right partners, and keep the species alive. Black was never the answer, and nature figured that out long before we thought to ask the question. If this changed how you'll look at flowers forever, hit like, share it with someone who loves nature, and subscribe for more. See you in the next one.